Topic 7-6, More Simplifying Radical Expressions. This can be referenced in our Holt textbook, Chapter 11, Section 6, starting on page 805. And we're going to do a few more and do a few other things with perfect squares, and we're going to introduce division. You've been looking at problems that have multiplication, but I want us to look closely at numbers like number 2. Now let's look at this first one. You've got negative 5, x to the 3, y, multiplied by the square root of 18, x to the 5, y to the 6. Start by looking for a perfect square. We know that 9 is a perfect square inside of the 18, so 2 times 9 is 18. So 9 has a pair, where 2 stays, it's going to stay under the radical. 5, remember there's an odd man out. 2x to the 2's give me x to the 4 with 1 left over. An even number can be divided in half. You've got 3 and 3 would be 6. So you do have a pair. Let's move this another way. But you got to be careful because you got a number on the outside. So you have a pair of 3. Negative 5 will be multiplied by the 3. The x to the 2 will be combined with the x to the 3 on the outside. Your pair of y to the 3's will be combined with the y on the outside. And then I think we're through with everything underneath, so what's left under is what was boxed, the 2 and the x. So again, these are large problems, but if you go slowly, it can be answered and carefully, right neatly, and you'll be able to get this. So you've got negative 15, combining these two x's, and you get x to the 5. Remember, you're adding. This is a 3 understood, and this is a 1 understood. So this is going to be y to the 4, square root of 2x. I'm going to squeeze my... got a little close to my other problem. Alright, for number 2, I want you to look closely. You're going to look for a perfect square first. So that's why I put my calculator here. 64, the second square root of 64 is 8. Second square root, so it symbol's right there. Second square root of 81 we know is 9. So if you add a couple of zeros, you've got 90. So that's where I got 8 and 90. But we're going to show how that actually can reduce as a fraction. But let's try to remember, I didn't actually show it, but this is an even number, so I can get a pair of 9's, because 9 and 9 added together is 18. Notice it's the multiples of your whole numbers, the addition of your exponents. There is a different thing going here. So you've got 90 times 90 is 8,100. H to the 10 plus h to the 10 give you h to the 20. We just have to remember our rules of adding exponents in multiplication of bases that are alike. Alright, 8 divided by 90. If I put that in a calculator, 8 divided by 90, I'm going to get this decimal form, but if you change it back to a fraction with your math enter button, you actually will get the reduced fraction of 4/45. And so keep it as the reduced as low as it can go, and keeping your g to the 9, h to the 10. So that would be your final answer for that one. I'm going to put boxes around these. Okay, look at number 3. Alright, we're not quite, I didn't finish it completely. But you want to look at this and say if it's not a perfect square. In fact, you could go to your calculator and, let's clear that out, and put second square root of 363. That's not a perfect square because it's giving you a decimal value. So let's try, if it's not a square, do this technique next. This is all underneath the radical, so let's divide it. If you say 363 divided by 3, watch what happens. You actually get a number, but if you square root, that actually is a perfect square. So 121 has a perfect square, so let's just do the division of this to where you can even put a 1 here if you need to. but you have a 1 left over. All right, you've got an x to the 5. And so we're doing the division. In division of exponents, the rule is to subtract. So x to the 5 over x to the 1 is x to the 4. To visualize this, think of it this way. You've got a y on the top, and you've got 3 y's on the bottom. If you cancel these out, how many y's are left in your denominator? 2. So that's where these count, showing a lot of the factorization. I didn't show it written out. But the square root of 121 is actually 11. We just determined with our calculator. The square root of x to the 4, since it's an even number, it's a x2 would be, you need to write that out, x2 underneath your radical. Here's your pair. This one is the square root of y2, which that's a pair of y's. If you need to show it, a y with a y. So your answer is just y underneath. I know this was a long drawn out one. Pause this. Look at it closely so you can get that. That's your answer. Took a while. Alright, look at number 4, 5, and 6. I ended up circling these problem numbers because you need to realize that this is a different look. These are squares. It's saying what times what gives me 100. So just like when you're having to do, you might have seen this when you're dealing with Pythagorean theorem. Anytime you take, if you're trying to find x by itself, you're going to take the square root of it. So that just becomes a pair of x's, if you remember in your circling in your factor tree. But this is a pair of 10s. So that's taking the square root of, just remember this, you're actually, it is in 2 answers. You're always going to be able to have a plus or minus 10 for that answer. So each one of these you're going to have a plus or minus. The only way this one and this one are different is that you first want to isolate the 2m squared by adding a 98 to the other side. Whatever I do to one side, I'm going to put it on the other side too, so that you have 2m squared, this one away, is equal to 98. You want to get your m squared isolated, so you're going to divide by 2. So m, that goes away to 1. So m squared is equal to 49. Taking the square root of both sides, anytime you have any variable squared, you're going to take the square root of it to get its, and this happens to be a perfect square. Just make sure you put a plus and a minus with that one. Alright, same thing with this one. You've got add 500 to both sides. That goes away. This helps draw a line. 45a squared is equal to 500. You're going to divide both sides by 45. So your a squared is now equal to, what is that? That actually just is a reduced fraction. If you put that in your calculator, you're going to get a decimal and then change it back to a fraction, and you'll get 100 over 9. Well, guess what? If I take the, I'm using my pink, square root of both of, these, get in the habit of be looking for perfect squares. So this is going to stay a fraction, but it's 10 over 3. And make sure you make that a plus or minus. Anytime, because you can add, you can multiply 2 negatives to get a positive and 2 positives to get a positive. And that actually concludes the last section, 6, for Unit 7.